Hey everyone, my name is Aiden Vaughn. Today, I'm going to talk about something that happens in your chest every second of your life, but that most people never think about. How your heartbeat actually starts. We hear the beat and we feel the beat, but what makes it begin in the first place? I'm going to walk you through the basics in a super simple way based on research from the Bresson Lab here at UNC, which studies how the heart's natural pacemaker forms and works. When most people think about the heart, they imagine a pump that squeezes blood throughout the body. And that's true, it is a pump. But what most people don't realize is that the pump only works because it's controlled by electricity inside the heart. Every single heartbeat begins with a tiny electrical spark. This spark tells the heart muscle, okay, it's time to squeeze now. Without that spark, the heart wouldn't contract at all. And this isn't something that happens every once in a while. This tiny spark goes off about 100,000 times a day, every day, for your entire life. So before we talk about pacemaker cells, the idea is that your heart can only beat because it creates its own electrical signals. We usually picture the heart as a pump, but no pump works without something to start it. In our bodies, that starter isn't a switch or a battery. It's a tiny patch of cells called the sinoatrial node, or SA node for short. This little region is only a small part of the heart, but it acts like the spark plug that fires the very first signal for every heartbeat. Heart muscle cells have stripes called striations that help them squeeze in perfect rhythm, but they can't do anything until the SA node gives the command. To get an idea, imagine a stadium full of people waiting for one person to start the wave. The SA node is that one person. It creates the signal, and all the other heart cells follow. That's why understanding what the SA node is so important. It's the tiny place in the heart where the whole heartbeat begins. Inside the sinoatrial node are the real stars of the heartbeat, pacemaker cells. These cells are very different from the regular heart muscle cells that squeeze to move blood. Pacemaker cells don't wait for any instructions from the brain or from nerves. Instead, they can fire off electrical signals completely on their own. That's why we call them pacemaker cells. They set the pace of your heartbeat. Once they fire their signal, that message spreads across the heart and tells every other muscle cell when to contract. Imagine it like a group text that goes out to all the heart cells saying, okay, guys, time to contract. These cells are tiny, but they're the reason your heart stays in rhythm second after second and day after day. They are similar to a built in metronome. Pacemaker cells don't just fire once, though. They fire in a repeating cycle over and over. The picture you see here is a very simple version of that cycle. You don't need to worry about any of the labels, but the main idea is that pacemaker cells slowly build up an electrical charge, release it in a quick spark, and then reset themselves to start the cycle again. As they go through this cycle, build up, spark, reset, repeat, the heart gets a steady rhythm. The reason this image is helpful is because it shows that pacemaker cells are always active. They're constantly working through this electrical loop that keeps the heart beating, and they don't need any outside help to do it. This is how they create the natural rhythm that spreads to the rest of the heart. One of the big ideas from the Bresson lab is that pacemaker cells don't just depend on their electrical cycle, they also depend on their environment. These cells work best when the tissue around them is soft. When the tissue becomes stiff, their signals can slow down, become uneven, or stop coordinating properly. You can imagine it like tapping on a soft surface versus a hard one. The feel changes the rhythm. In the same way, soft heart tissue helps pacemaker cells keep a steady beat, while stiff tissue can throw them off. The Bresson lab here studies this connection to understand how the heartbeat develops and why abnormal rhythms in the heart can cause problems. Thank you so much for listening. Pacemaker cells may be tiny, but they keep our whole lives moving. And it's exciting that research from places like the Bresson lab at UNC are opening doors to new ways of treating heart conditions down the road. So the next time you feel your heartbeat, you can think about the tiny spark and all the coordination working behind the scenes to keep it going.